we'll go ahead and we'll take a question from Snyder and Nicholson. So, this is the first question from Snyder and Nicholson, and this is from chapter 3 of Snyder and Nicholson. Let's look at the question. Graph a typical indifference curve for which utility function, for the following utility function, and determine whether they have convex indifference curves. Now, convex ICs are the one which have diminishing MRS. So the first aim for you is to find MRS. Once you find this MRS, you will have to check whether this diminishes or not. Now just look here, okay? So MRS is the slope of IC, right? And if I draw my indifference curve like this, and I take X here and Y here, diminishing MRS means that the slope becomes from steep to flat. It reduces. So which means as I increase X, MRS must decrease. The slope must decrease, which means how MRS changes as X changes, this must be negative. There is an inverse relationship between X and MRS. So as X increases, MRS decreases. Inverse relationship. So change in MRS. When there is a change in X, this is less than 0. They move in opposite direction. Be very clear with this, okay? Now let's go to the first part. So my utility function is given as 3x plus y. We all know that this represents substitute goods. What does it mean? It means that this is of the form ax plus by, which is a linear indifference curve. And if I want to find MRS for this, this will be mux by muy. How do you find MRS? You ask the question, what is MUX? So how utility changes as X changes, divided by how utility changes when Y changes. Quickly differentiate this utility function with respect to X, holding Y constant. What will you get? You will get 3. Differentiate this with respect to Y, holding X constant, you will get 1. So your MRS is 3. Actually, we know that for linear ICs, which are substitute goods, the MRS is given by A by B. Here, this is A and B is 1. Is this clear? Now, let's graph this. So the slope is 3, right? Slope is perpendicular by base, right? So 1, 2, 3, 1. This is my IC. And the next will be 4, 5, 6. Here it will be 2. This will be my IC. So these are my ICs. So it becomes an indifference map. Clearly, you can see that the MRS is constant. This is not diminishing, it's constant. So we don't have diminishing MRS. MRS remains constant throughout the IC. But can we go ahead and prove this? Yes. Let's go ahead and ask how MRS changes as X changes. Do you see any X here? No, this is a constant. So its differentiation with respect to X will be 0. 0 is not less than 0. It is not negative. It's 0. So MRS does not change. Does not change means does not decrease, does not increase. It doesn't change only as X changes. It is constant and not diminishing. So you have constant MRS and not diminishing MRS. So this is your first answer. Is it convex? No, it is not convex to the origin. It is a straight line. So ideally speaking, mathematically, it is still convex. Maths considers equal to also convex. But we will go ahead and say that it is not strictly convex. This is what we want to check. Do we have diminishing MRS? No, not diminishing MRS. In fact, what do you have? You have constant MRS. And how is your utility function? Linear straight lines. This is your answer to part A. Is that clear? Okay,